Hello.
Hello. Wonderful. Can everyone just put your names and also mention the name of your country with your names?
Yes.
Plus, besides your name, don't need to read it out. Just we want to see what your country is. So, for example, Rachna Kumari, then mention the country that you're from.
Ma'am, I mean, sir. Sir, my name is Satwik. Actually, Rachna Kumar is sitting because his my mother's name. I'm from India.
Wonderful. Thank you. Just mention it there.
My name is Dev. I'm from India, but I live in Dubai.
I'm from Bangalore.
Good to know.
My name is Ritvik Rathi. I am from India.
Wonderful.
I'm
from Pakistan. Which country?
My name is Muhammad Yan Bilal. I'm from Pakistan.
My name is Tonel. I'm from Sri Lanka.
My name is David
Hi,
and
my
I
name
live
is
in
Rishabh.
Singapore in Malaysia.
Hello, my name is Tarish. I'm from Bahrain.
Hello, my name is Shanti. I'm from India.
I'm from Sri Lanka.
My name is Dev. I'm from India.
My name is Skylar. I'm from South Africa.
My name is
from India.
My name is Devrat
Wonderful.
Pardesi from India.
My name is Gar.
My name is and I'm from Botswana.
Okay, great. So now our admin will put everybody on mute, and I would request everyone to, make sure that you mention the name of your
Sana
country
from
besides your
Pakistan.
name. Just write the.
You're muted, Avinash.
Oh. Can I request everyone to write the name of your country besides your name, please? All right, I think it's time, and now we can start our session. I really would like to thank everyone for having joined this session, and uh, you know, it's great to see so many faces here. We are at this point close to 200, and I'm sure a lot more are going to be joining in from all over the world, various countries participating, more than 56. So before we start the session, I would want everyone to just go through the screen, and there are certain basic rules that we would all need to follow. You've all been put on mute, but there will be times when we will be asking for volunteers to interact with us for any topics. So you can volunteer, and we will then unmute you, and we can speak to you at that point. If you're facing any problems in listening to us, or if you can't see something, then it's best to put your cameras put your camera off. And at that point, you'll probably be able to see or hear better. So that's for you. If you have any questions, you can put it on the chat box. For any competition related questions, you can drop us an email at contact@livemcl.com, or put us a WhatsApp on +91 82910 27238, and we will answer those questions. Today's session is for learning mental math tips and tricks, which are focused on the Grandmaster category. So we just will be focusing on that. Any questions relating to how the competition is being held, or if you have any questions regarding the app or login issues, will be taken in when you email us or write to us on WhatsApp, or if we have any time left towards the end. But again, our initial target is to make sure that we stick to the mental math tips and tricks sessions. Okay. With that said, let me first start with the introduction of live math competitions and leagues. Live Math Competitions and Leagues is dedicated to the promoting of mental math skills through engaging and challenging competitions worldwide. We provide a platform for students like you to showcase their mental math skills and abilities to learn, grow in a competitive yet supportive environment. Our mission is to make mental math accessible and exciting for everyone, regardless of their backgrounds. So we are thrilled to announce that the Mental Math World Cup is now in its third edition. This event gathers young math enthusiasts like all of you from across the globe, giving them the opportunity to compete, learn, and excel in mental mathematics. We are proud to have participants from more than 55 countries, 56 at this point. We hope that we'll have some more countries joining in the coming last few days. So why are we here today? Today we are here for the Grandmaster Mental Math Tips and Tricks session, as well as for those participants who have joined the Zenmaster event and they want to be competing there. So today's session will be focused on that, and we are most honored to have someone like Mr. Daniel Timms as our trainer for this session. Daniel is not only a mental math trainer, but also a software developer. He's an international mind sports competitor who competes in various competitions around the world, and he's one of the best in business at this point. And he's also a STEM education professional from UK. He loves exploring the world with a location-independent lifestyle and is currently logged in from Bulgaria. He's here just to ensure that all the participants who have joined Mental Math World Cup, and have joined the session for this call today, learn techniques that will surely make a big difference to your mental math skills. With that said, I would like to pass on the baton to Daniel to take the session forward, and I'm sure it will be a great session. Okay, Daniel, over to you now.
Sure. Thank you very much, Avinash, for the introduction. So as you said, I'm Daniel Timms. I'm from the UK, but I spend much of my time traveling. At the moment, I'm in the mountains in Bulgaria. Nice to see so many people joining from so many places in the world, including many countries that I haven't visited. I hope to one day. And so just a little introduction to me. So this workshop, as Avinash said, is about important methods for the Mental Math World Cup. So some tricks and tips for the different categories. A little about me. I studied mathematics at university. I graduated about 13 years ago. I'm 33 years old now. I worked as a software developer, and then in 2016, I left my software job and started traveling. In 2012, I joined my first international mental maths competition, and since then I've competed many times or helped at many events, including, of course, the Mental Math World Cup that you are all preparing for. I also work as a mental math coach at events, which is what I'm doing right now, and I run the World Mental Calculation website, and there will be a couple of resources that I will share with you on that. This page kind of broke, but in this, the topics we are going to cover are multiplication, percentages and square numbers, division by 1-digit and 2-digit numbers. To help you with multiplication and division, there's a training exercise involving addition and subtraction that will make you faster at these multiplications and divisions. We will also look at cube roots and square roots, and at HCF and LCM. That means highest common factor, lowest common multiple. We will see more when we get there, and there may be some time at the end for questions and answers. And so just to start, there's more than 300 of you joining this workshop. So of course I can't have a conversation with everybody because there are too many people. So what I'd like you to do is, if I ask you a question, sends the answer to me in the private chat. So if you look at the chat window, you have the option of sending a message to Daniel Timms UK, that's me. So can everyone just send a private message to me, just saying like, hello. Okay, and so right now you can imagine I have hundreds of people sending me messages, very nice. I cannot reply to everybody, but yeah, awesome, this is working. So please don't send me messages unless it's important, but I will ask you some questions and you can send me the message in the private chat. And in this way, I understand whether people are understanding the content I am teaching or whether I need to explain things a little more. If I ask a question and you don't know the answer, maybe send me some, maybe send me some question marks like this, and then I'll understand that people aren't understanding the answer. Anything else I need to say as the introduction before we begin? No, I think that's everything. So the first topic we're going to look at today is multiplications. And I'm going to share the screen. So, okay, first of all, easy question to begin with. What is 34 times 8? So answers in the private chats. Yeah, really good. I see lots of correct answers here. And so I'll just put it on the screen. So yeah, the correct answer is 272. So really nice to see lots of answers quickly here. So just some words that you should know to do with multiplications. Each of these numbers is called a multiplicand. So a multiplicand is a word, it is a number that you multiply. And if you multiply two numbers together, then you get a product. So these are some English words that are useful to know about mental maths. So just the basics here. How do we solve these? The answer is going to be 30 times 8, which is 240, plus 4 times 8, which is 32. And the answer, therefore, is 272. So this here, hopefully, is very basic. When we do this with larger numbers, you will find it's many people prefer to do it from the left to the right. So if we have a calculation where it's not just 34, but many numbers, like 6,794, then we can work from the right and move to the left. And I'll show you that. How do we know what 30 times 8 is? This is from the times tables. So this slide is about the basics. So we have the basic method here. It's also important to know. Times tables up to 9 times 9. So it's really important to know these. So I know that 3 times 8 is 24. Equals 24, and that means that 30 times 8 has to be 240. So this is just some basic properties of the of multiplications. So let's I'll do another example here that's a bit more complex, and then I'll give you another example to try yourself. So the example I'll give is 5,682 multiplied by 7. And the way I would do this is I would say 2 times 7, that's 14. I know now that okay, yes, some correct answers coming in already. I know then that the answer has to end in 4. Then I take the 4, I carry the 1 from the 14, I write down the 4, I carry the 1, and then I have a look at the 8 times the 7. 8 times 7 is 56. Plus the carried digits, which is the 1. And that gives me 57. So I write the 4 and carry the 1. So I do that now. I write down, I'm now going to write down the 7 because that's the last digit of the 57. And I carry the 5. So write 7 and carry the 5. And I just repeat this process again and again. So I've got the next digit I have to look at after reviewing the 2 and the 8 is the 6. So I now multiply the 6 by the 7. So 6 multiplied by 7, which I know is 42, if I learned my times tables well, plus the carried digits. In this case, it is the 5 from before. This then gives me 47. Then I can write this 7 and carry the 4. And then, so I'm going to do that, write the 7, carry the 4, and then finally I look at the last digits. So notice here, during the calculation, I'm starting from the right of this number and moving to the left. I'm splitting the 5,682 into numbers that I know how to multiply by 7. So I multiply the 2 by the 7, the 8 by the 7, the 6 by the 7, and finally now the 5 by the 7 to put everything in its correct place. And so just to finish then, 5 times 7, that's not 7, 5 times 7, which is 35, plus the carried digit of 4 is equal to 39. And now I've finished, I can simply write down the 39. So the final answer should be 39,774. I see someone sent me a message saying the method is so long. The method is very short, but we have to do, because the number we are multiplying is so long, we have to do the same step 3 or 4 times to finish the question. So everyone who got the answer 39,774, yeah, that was correct. Good job. And if you made a little mistake, that's okay. These things happen. Let's try, question, I have lots of questions coming in. So does it, will it take very long to finish the questions? Well, with practice, you can do this very quickly. With practice, this might take you less than 10 seconds. If you haven't practiced much, then maybe it takes you 1 minute, and that's okay. And some people, do we have to write the method in the exam? No, you don't have to write anything for the exam. You just need to select the correct answer. And I will give you some more hints on doing that quickly in a moment. Should we calculate all the digits of the number? Well, if you want the answer, then yes, you need to calculate all of the digits. But because the questions in the Mental Math World Cup are multiple choice, then there is a shortcut that I will show you later. Another question, why 39 and not 9? Well, okay, I can write down the 9 and then carry the 3, but then I don't need to do any other multiplications to add on. So then I kind of have the 3, I add 0 to it, and then I write down the 3. So eventually I have to write down the 3 However, I understand the method. Question, what happens if it is a bigger number? If the 5,682 is a bigger number, then I just continue this method for longer. If the 7 is a bigger number, then we need a slightly different technique, and that is what I will show you next. Can we also start from the left, as it's easier to remember the previous digits? You can write the digits down so you don't need to remember anything, but yes, you can, if you prefer to start this method from the left, if you like doing that, then that is totally good as well. Nitik from India, you have a good idea. I will say more about this later. Will I have time to solve it in this method? Hopefully, yes, when you have practiced, but there is also some shortcuts. Is there a faster way? No, this is the fastest possible way because we need to look at the 2 and the 8 and the 6 and the 5. The question is just quite a difficult question. In the competitions, can we use pen and paper? So any questions about the competition, you should direct these to the organizers. But for this question, the answer is yes. You can use pen and paper, but you select the question electronically. So yes, if you need to write down some of these numbers to help you do the question, then yes, you can do this. Just looking at the last questions. Any sources provided to practice? So the team at Live MCL have got various resources they can point you to, and those are good resources for practicing. Is this multiple choice questions? Then we can just do the last step. Yeah, so I'll talk more about this in a method. Can you please solve another question in the same way? Yes, we are going to do that. For the exam, are the questions timed? Yes. Okay. There's a lot of questions coming through. I can't answer everything. So please don't send me the same question many times.
Let me just address that. To all the students, let's just focus on the methods of doing quick calculations at this point. What is going to happen in the test is something that we will answer. Just write to us on 8291027238 or email us. We will answer those questions for you. Don't worry about that. There is a step-by-step guide that has been shared, which has all the details of the same. So what we need to do is make sure that we are focused on learning the techniques at this point and making the most of the time that Danielton spends with us. So let's just focus on the topic right now.
Yeah. Okay. So let's do a couple more practice questions like this before we go on to the cross multiplication. So new question coming in. Cool. I see lots of answers, some incorrect answers, but lots of correct answers. Your final answer should have 5 digits. Should have 5 digits. Okay, cool. I see a lot of people have the correct answer, which is 70,600. And so the way of doing this is you can do the 5 times the 8 to give you 40. So I write down the 0, and then the 2 times the 8 plus the 4 that's carried is equal to 20. 8 times the 8 is plus the 2 that we carried is equal to 66. So I write down the 6, and then the last 8 times the 8 plus the 6 is equal to 70. And so if I read the answers backwards, I've got 7, 0, 6, 0, and 0. Some people prefer to do the method backwards. That is also totally fine. If it works for you, that's great. Okay, so this is just the how to multiply by a number where you know the times tables. So here we use the 7 times table and the 8 times table. Very simple. The next thing I'm going to look at is what happens if I have to multiply by a large number where I don't know the times tables. Yeah, so a few people asking, could you multiply first by the 8,000, then the 800, then the 20, then the 5? If you prefer that, then yes, it doesn't make a difference for it. Which method is better? For me, it depends like why I'm doing the question, what I'm trying to do. For this one, I would do it from right to left, as I explain. But if someone tells me the question with smaller numbers, then I would do it left to right. So next question here is multiplication by large numbers. So for example, how would we do 345 multiplied by 67? So maybe some people can already answer this question. In the meantime, I'm going to explain a method for doing this. And here, if you know your 67 times table, then great, you can do that. But what I'm going to recommend instead is to start again from the right, as I just explained. And I'm going to multiply, first of all, the last digit 7 with the last digit 5. But some people prefer to do this backwards as well. So starting from the right, we have 5 times 7 is equal to 35. So then, therefore, my answer is going to be something ending in 5. So write the 5 and then carry the 3. But what do I do next? I've only looked at the 7. I am going to move backwards along the longer number. So that means that now I'm going to have a look at multiplying by the 4. So now I'm going to do 4 multiplied by 7, which is 28. And I'm going to add on the carry digits. So I've got the 3. I'm going to add on the 4 plus the 7. And that gives me 31. And then remember that the 28 is 40 times 7, not just 4 times 7. So it's not 28, it's 28 tens. And there's another way that we can get tens here, and that is if we have 5 times 6. So I also, at this stage, I need to work backwards and not just multiply the 4 and the 7, but go inwards and do the 5 and the 6. So I add the 5 and the 6, which is 30. And then adding all of these together is going to give me 60. That's not right. It's going to give me 61. So just to repeat where the calculation came from, I moved, first of all, 1 digit to the left to multiply the 4 by the 7, and then I move in the same part of the calculation, I move inside. So I multiply the next digit to the left of the 7 with the next digit to the right of the 4, moving in towards the center, in towards the multiplication symbol. So what happens next? With the 61, again, the 1 is the digit that I'm writing down. And I have to carry that 6. I see a few people sending, please, if you send me a message, only send me once. So the next thing I'm going to do is the same process. Move the star one more digit in this direction, and then continue that way. So I start off then. Okay, right 1, carry 6. I'm going to start with the. I'm going to start multiplying now the 3 by the 7, and I should know that's 21. And so if I add the 21 to the 6, that gives me 27. And now I have to move inwards along the dark blue arrows. So if I've multiplied the 3 by the 7, I now go inside. I move inwards towards the multiplication symbol 1 digit. And so now it has to be the 4 multiplied by the 6. So 4 multiplied by 6, which I know is 24, I add that onto the 27, and I get 51. So again, the units digit, this is the new digit that I can write down. So I write the 1, and I carry the 5. And then I can continue. But at this point, the 3 doesn't get, I can't move on the first number, the 3, 4, 5, I can't move this star any further because there's nowhere for it to go. So if I want to move to the left, I have to move this star into the middle as well. So the next thing I multiply is the 3 times the 6. So I have the digit that I carry, the 5, plus the 3 times the 6, which is 18. And then again, I try to move in this direction, but 6 is already the last digit. So I'm finished. Finally, the question is finished with the 23. So finished, so write 23. So I've already written my 1, and now I write the 23. So this here is the shortest method to multiply these numbers unless you know the 67 times table, and that's difficult. So everyone who got the answer 23,115, then yeah, good job, that's the correct answer. I will go through the method explaining again because this could be, yeah, a few people finding this difficult. So I'm starting, look at the thing in black. I am starting from the right. So I start with the right digit on both numbers. And I'll make a note of these as well. So I start with the rightmost digit of both multiplicands. So in this case, that's the 5 and the 7. Multiply these, write the units digit, which is the 5. So multiply these, gets me 35. Write the units digit, which is 5. And carry the rest, which is the 3. So then for the next digit, I'm going to, so on the first number, which is the 345, move 1 digit to the left, which is the 4. Multiply this by the 7. You need to add the carry and then move 1 digit on both numbers towards the multiplication. So if I've looking at the black number again, I've multiplied 4 multiplied by 7, and then I have to move 1 digit in, 1 digit inwards. So towards the 5, and here towards the 6. And so the new ones I'm multiplying are the 4 multiplied by the 7 and the 5 multiplied by the 6. And then I just continue this process. So every time I need to find a new digit, I move 1 step to the left of the right of the left number of the 3, 4, 5, and I keep at the same digit with the 7. So yeah, that should be a multiplication here. Thank you. And then move inwards. So let's try another example. And then I'm going to ask for a volunteer to...
Daniel, just one thing. To the kids who you know, if you think that this is a bit difficult at this point, please remember everything, you know, the basics of multiplication is, you know, you should know the multiplication of the single digits. So 1 digit multiplication is something that you should master in any case. After that, these steps that Daniel has shown us over here is something that is how you start learning the mental math technique. You will find it difficult today, but if you keep practicing and keep at it for a few days, you'll be able to do it mentally, and then that will transform you from there onwards. So that's all I would say. It's not it will never be something that you can do it in one shot. You'll have to keep practicing. That's it.
Good. Thank you, Avinash. Yeah, and this is very true, that for multiplying, let's say 8 times 9, you know the answer from memory directly, but for more advanced mental maths like this, you need to do it in several stages. And so in this case, we need to break up the question into multiplying the 5 by the 7, the 4 by the 7, the 5 by the 6, the 3 by the 7, the 4 by the 6, and the 3 by the 6, all these different stages in the correct order. And if you have practice with this, then the calculation becomes actually not too hard. In the private chat, I have some people who are sending me messages saying that the question is very easy, that it's very basic, and other people saying that it's very difficult, that the calculation is very long and that they find it confusing. So remember that if you're finding this confusing and you're finding this difficult because it has lots of steps, after time, you will also be able to find this easy.
And the recording for this will be available for you. You can reach out to us and get a link for the recording, and keep watching it a few times, practicing along with that, and you'll be able to master it.
So let's try another example. So, and this method is the one that means with this method, you can do any multiplication of any numbers. So new question we're going to have is 378 multiplied by 54.
Daniel, would you want to do this with a volunteer?
Yeah, I was thinking that. Yeah, so a volunteer who's using the same method, because some people are using different methods. I'd like a volunteer who's using the same methods.
Exactly. So admin, if there's anyone that would want to volunteer, and if they have, and what we need is we would want them to follow the exact steps that is shown by Daniel, and that's what we want to do. So let's pick someone to do that. should we get Ashley Colaco?
Yes, sir.
Ashley, so would you be able to do the same steps that Daniel just explained? We'll work together on this. Would you be able to do that?
Yes, sir.
Okay, awesome, thank you. So how would I start?
So the thing I did was start from the left, but still for now I'll do from the right. So first off, 4 times 8 would be 32.
Good, yeah.
Then I would say 7 times 4 would be 28, but since it's 70, it's 280.
Good, yeah. So the first thing is that I can already write down the first digit. I know that the answer ends in a 2. And those of you who are sending me messages about the multiple choice question, this is important that we can already write down the 2. So yeah, what do we do next after we've written down the 2?
Okay, so like I said, we can do 7 times 4, which is 28, but there is also a carryover of 3.
Good, yeah.
So that 3 gets added to 8, so it becomes 31.
Good, yeah. So
Then
so
lastly,
to be clear, I've moved from the 8 to the 7, and so now it's the 8, it's the 7 that gets multiplied by the 4. And then what do I also do on this step, Ashley?
Okay, so next, after that, we had carry forwarded 3 and got 31. So next, I would say 3 times 4 would be 12.
So here, we're not multiplying everything by the 4. We're gonna, we're finding everything we need for the second digit. So what I'll actually do here, I mean, you have a different method there that also works. I'm gonna have a look at everything in this box, this 2-digit by 2-digit box. So I started by looking at the ends, the 7 times the 4, as you described, and then I'm gonna move in towards the center.
Okay.
And as you already said, that the 7 times the 4, it means 70 times 4. So when we have the answer of 28 or 300 or 31, it means 280 or 310, even though we are only thinking of the 28. But the other ones that is a multiple of 10 is the 8 times the 5, because the 5 is 50. So we can work inwards from there. So if I add the 8 times the 5, what do I get?
40.
Nice.
Wait, so 8 times 5 is 40. And then when we add it to 31, we get 71.
Good, yeah. So this gives us, well, equals, right? Equals 71. And which number do I write down?
1.
Good, yeah. I write down the last digit with a 1, and then I'm carrying the 3. In case it's not clear to some people, the reason we have the 3 here is because it got carried from here. So the digit that all the digits we didn't write down in the previous step, we remember them and we start with them in the next addition. Okay, cool. Ashley, what's next?
Okay, so we finished with 78 times 54 already. Yeah, we have the 3 remaining. Yeah, okay, so we have the 3 remaining.
Good, yeah. So the 3 remaining, we now have to look at the 3.
Yeah, so I would start with 3 times 4 would be 12. Oh,
good,
wait,
yeah.
36.
Yeah, so we've got the 7 digit that we're carrying, and that's got to add to the 3 times the 4.
So that would be 19.
Nice, yeah, good. And then what's next? Looking at this digit. So we've multiplied the 3 by the 4. What comes next?
Do we do 3 times 5 next?
That comes right at the end. So we've done the 3 times the 4, and now we have to go inwards along this 2-digit times 2-digit box.
Oh, 7 times 5.
Good, yeah, 7 times the 5. And so if I get the 19 and I add the 7 times the 5, what do I get?
54.
Good, yeah. So there's 54. and I'm going to remember the 5. I can only write down the 4. And then how do we finish the question?
So then we have to do 3 times 5, which is 15. Then we add it to 5.
Good, yeah. So the 5 that we've carried, we add it to this, and that gets me which number?
20.
20.
So the final answer is 20412.
Very good, yeah. Cool. Thank you very much for your input there. That's very helpful. And yeah, exactly. This is exactly how we can use this method here, which is called crisscross method or cross multiplication for multiplying together any 2 numbers. And for those of you who've got different methods that you prefer, some people multiplying 378 by 5 first, and then multiplying 378 by 4, adding those together. That method also works well unless you've got very large numbers. So imagine if I have this, that's not a number. If I have this, the method that I showed you here still works. And you don't have to remember so many digits. So the world record for multiplication, the people who have the world record for multiplication, they are all using the method that I showed you today. And they can multiply 8-digit numbers together in less than 30 seconds, the fastest people. 8-digit times 8-digit in less than 30 seconds. Do you have anything to add, Avinash?
Yes, what I wanted to say was this method will, if you want to really do big things with numbers, if you want to do really massive calculations, this is the way to go. What you meant, what some of the other kids are also talking about, and the method that Daniel talked about, that multiplying 378 by 5 and 378 by 4, that method also works, but that works for smaller numbers. But if you really want to do big number multiplications, this is the way to go. This is the only good way to go, actually. Daniel, can I request you to also, for the benefit of some of the kids, who just want to do the smaller numbers for now, can you, the method that you just spoke about, 378 by 5 and 378 by 4, and then adding the entire thing, just show it once to them. So for the others who just want to have a look at that?
Sure, yeah.
Yeah.
So I'll take the same example. In fact, maybe, should we have a volunteer who wants to use that method?
Sure. Who would want to do that?
So someone who is doing it like 378 multiplied by 50, and then 378 times 4, and adding these together. So
how about Pareshi? Pareshi Midha, would you want to try that?
I have someone called Andre who also requests. That's also possible.
Okay. Let's get Andre then. Yes.
Yeah. Hello. Yeah.
So yeah, Andre, how would you do the same question, 378 times 54?
It was quite simple. Well, so you told us to, first of all, I'm going to start with 4 times 8, which we get an answer of 32. Okay.
Yep.
And then now we would multiply 4 and 7. It's quite simple. So originally we'll get an answer of 28, but due to the number 3 from before, we add that, so we get in 31. And then now we multiply 4 and 3, which we get an answer of 12. But since we have 31 from before, it's now 15. So right now we have an answer of 1,512. Well, we're not done yet. So 5. Now we move on to the digit 5. Okay, 5 times 8, 40. 5 times 7, 35, but due to the 40 from before, and it's now 39. And then lastly we have 3 times 5, and then like we add 3 from before. So now we add 1, and then we add a 0 behind our answer of 1,890. So which makes it 18,900. We add this and our remembered 1,512. We add this together and we would get an answer of 20,412. Thank you.
Cool. Very good explanation. Very clear. Thank you, Andre. I'm trying to catch up with the writing here. And I think I've got this correct. So this gives 1895 with a 0. And then you finish with the addition. And if I've got all of the calculation correct there, should be 18900. Then you add these together. So 18900 plus 1512 gives the same answer, 20412. So there's several methods that you can use. This one, maybe people find it simpler, the method that Andre shared in red, and many other people were telling me that they use this method. And the other one that's very popular is the crisscross method or cross multiplication. And if you need to multiply really big numbers together, then the crisscross method means you don't have to remember these large numbers. So the red method is simple, but I need to remember the 1,512 and the 18,900 before I add them together. And that's not needed in the that's not needed for the crisscross method or cross multiplication that we started with. So
wonderful.
This is difficult. This is complex, of course, and so it's something that you need to practice, do some slow examples, and at the end of the workshop, I'll give you a link to another explanation that shows you how to use the crisscross method for even larger multiplications. The next thing I'm going to do is talk about how how you can use multiplication with the multiple choice answers of the in the Mental Math World Cup to get to the answer even faster. And sometimes you can avoid doing some of the calculation. So let's say I have this question here. So this is obviously a really difficult question. I want to know what is the last digit of the answer. So just the last digit. Okay, really good. I see lots of correct answers coming in. The last digit is going to be 6. And the reason we know this is because when I start using cross multiplication, or when I start with the method in red, the first thing I do is multiplying. Here it's the 8 times the 4. Here it's multiplying the 9 times the 4. So if I do 9 multiplied by 4, I'm going to get a 6. I can write down that 6 already, and then nothing else is going to change that. So I start with 9 times 4 equals 36. Write down the 6 and never change it. Therefore, answer ends in a 6. And we don't need to do the rest of the question to know that the answer ends in a 6. So if I'm doing the Mental Math World Cup and I find I have a really difficult multiplication, and I think that the multiplication methods are difficult, they're slow, I find them really a challenge, then what I can do is multiply. I can start doing the method and then look at the multiple choice options. So if I have an answer, if I only have one answer that ends in a 6, I know it's the correct answer. And if I have, let's say I have 2 answers that end in a 6, then I don't know. Then I don't know what it's supposed to be. But at least I know it's one of the options that ends in a 6. So if I don't have much time, I can guess even. I can guess it's one of the answers that end in a 6. But is there a better method that doesn't involve guessing? Well, I can continue and work out the next digit. And if I'm doing cross multiplication, then it's easy for me to work out the next digit straight away. So the next digit here is going to be the 3 that I carried, plus I'm now going to move 1 block to the right and compare the 69 with the 84. So I'm multiplying the 6 at the end with the 4 at the start. So this now is just the same as cross multiplication or crisscross. So same method with crisscross. So I've got the 6 times the 4, and that's going to get me 27. And then I'm going to add the 9 times the 8, because remember, with the crisscross method, I work insides. I start at the outside and I work insides. And so I now do the 9 times the 8. 27 plus the 9 times the 8 gives me 99. I think I've got that right. And so if I'm doing cross multiplication, I can write down the 9. This means the second 9, the 9 in the 99. Therefore, the answer ends in 96. So now I can look at the options, and hopefully only one of the options ends in 96. So if only one option ends in 96, it must be correct. And I don't need to continue with the calculation. So someone already told me the answer. It's a huge number for this calculation, but if the multiple choice questions only has one that ends in 96, then that must be the right answer.
So kids, as Mr. Timms just mentioned, he showed us a lot of methods over here. He showed us the simpler methods also. He's shown us the crisscross method, which helps in big numbers. So, and then he's also showed us, when it comes to the Mental Math World Cup, what are the quickest ways to, sometimes if you don't have the time to calculate the whole question, what are the shortcut way to get to the, make an educated guess, make a very calculated guess. If you're short of time and you want to make sure that you are as accurate as possible. So these are all about making the right decisions, but also, when it comes to multiplications like this, Mr. Timms, the method that he showed, it will help you to do really big calculations in the future. Just you have to practice them. You have to keep on practicing and master it.
Exactly, yeah. Yeah, thank you for the summary there. And I'm going to finish with just a summary of everything we've done for multiplication, so you know what to do with this information after the workshop. So first of all, need to know the times tables up to 9 times 9. Hopefully everybody knows these fairly well, but if not, this is the first stage, to know the times tables very well. The second thing is we need to multiply, for example, what do we do? 300 and let's say 8825 multiplied by 8. Then you just use multiples of 8. So I like working from the right. Other people like working from the left. It doesn't matter. But you just use multiples of 8. So multiply by 2-digit numbers. What do we have? 378 times 54. You can use cross multiplication that I explained, or other methods if you prefer. So for example, the ones that I used in the red text, you can also use that method. But that's totally fine. You do the one that you prefer. To multiply really big numbers, use cross multiplication. It's the only method that works really well for really big numbers. For the Mental Math World Cup, which has multiple choice questions, then my advice is to look at the right digits and check the multiple choice question options for the last digits. And this means that you can solve the question quickly by using your understanding of mathematics rather than solving the whole question first. Imagine for the example here, where we start with 47,536,000,000, etc. How long would it take to multiply these numbers together? Even the fastest people might spend minutes solving this question, but we found out immediately it ends in 96. And then if only one of the multiple choice options ends in 96, then that must be the right answer. So this is the summary of multiplications. I've had lots of questions coming in. So how long is this meeting? 2.5 hours. May we use any multiplication method for the competition? Yes, I'm giving the methods I recommend the most, but you can use any multiplication method, and no one is checking your methods. They are only checking the answer. Okay, let's move on. Oh yeah, last thing for multiplication, I will give you another resource with cross multiplication, but I will give it later so that it's not a distraction right now. Of course, okay, so what happens if if we're doing the last question and there are 2 options that both end in 96, how do we know which one it is? Well, we just need to continue with the cross multiplication until only one of the options can possibly be correct. So maybe we can't finish with 6, maybe we can't finish with 96, but maybe if we do 1 or 2 more digits, then we can finish already. Okay, so next topic is going to be percentages. And so the multiplication is quite a difficult topic. Percentages is going to be a little easier. So little question here. What is 25% of 440? Lots of answers quickly. And can I have a volunteer? Can someone tell Avinash they want to volunteer to explain how they knew that what the answer was? Avinash, who should we select to? Who should we invite to share how they got the answer? Maybe Freddie. I know Freddie has the right answer.
So there are 2 ways. One you can do is because it says 25%, and we know that percentages are usually out of 100% in this competition. We know that 25 upon 100 becomes 1 upon 4. So we can say that 440 divided by 4 is equal to 110 because 4 into 100 is 400 and 4 into 10 is 40. So 4.
Really nice. Yeah, thank you. This is exactly what I want to demonstrate, that if a question says find 25%, it means find a quarter. So now I have an easier question, which is just what is 440 divided by 4, which is 110. And many people have got the answer. There's other methods, but this is the one that I want to mention at the moment. So questions in another question, answer in the private chats. So we know 25% is 1/4. What fraction is 75%? Okay, oh, everyone is so fast. Yeah, very good. So the answer is 3/4. Yeah, very good. And which other ones are useful to know? Let's take another one. What fraction is 20%? Yeah, very good. I can't believe how fast everybody is here. I'm very impressed. Yeah, so 1/5. So in the Mental Math World Cup, many of the percentages you have to use are simple percentages that you can convert as a fraction. So you need to know that 25% is 1/4, 75% is 3/4, 50% is 1/2, 20% is 1/5, and so on. And that means there's a very simple method of doing it. We have a question. What if there is a 57%? Yeah, good question. This is the next topic I want to do. So let's do one with 57% because this is an example that someone gave. So let's calculate 57% of, let's say, 3,100. So what would 57% of 3,100 be?
Do we want to volunteer?
I'm just collecting, I've got a lot of different answers coming in. Let's have, there's a couple of different methods. Yeah, any volunteer, because there's a couple different ways of doing it and they're all going to be good.
I can do it.
So yeah, what method can we use for solving 57% of 3,100?
So first thing we do is we write 57 upon 100.
Okay.
Multiplied by 3,100.
Okay.
Now we cut the zeros, which is we remove the 2 zeros of 100 and the 2 zeros of 31. They're cancelled by each other.
Okay, so I'm going to do it slightly differently, but it's consistent. So I'm going to find 1%, which is going to be 31. Okay, and so how would you continue?
Multiply 57 into 31.
Very good, yeah. So this is therefore 57 times 31, and then you can use your favorite multiplication method for doing this. How did you do it?
The crisscross, we just did it by normal multiplication.
Okay, yeah.
Which is, we just multiply 7 into 1 and then 5 into 1. And then we do the 7 into 3.
Yep.
Which is 21, and then 2 carry over. And then 5 into 15 plus that 2, which is 17. And then we add both the values, which is 1,761. 1,767, I'm sorry.
So yeah, I wrote you. That's exactly how we can do this. We can find 1%, or we can find 10%, and then we can scale it up. We have another method from Siddhanth. So can I invite Siddhanth to share your slightly different method, which is also good. Siddhanth Venkatesh.
Do we have Siddharth?
Yeah, Siddhanth.
Prakhyath, have you unmuted Siddharth?
Yes.
Hello.
Yes,
Yeah, hello.
Siddharth.
Yeah. So my method to solving this problem was basically, so we have the number 3100 and we have to find 57% of this number. So basically what I started with was finding 50% of the number. So basically dividing it by 2, because that's pretty easy. And the answer should be 1550.
Nice.
So we have this, and then what I did was find 5% of the value given of 3100, and this. And
Good, yeah. So 5% is how much? I think maybe we've lost Siddharth. But yeah, so we can. I think Siddharth has been muted for some reason. Can we unmute Siddharth, please?
yes, sorry. So yeah, so as I was saying, it would 5% of 3100 would be 155, and
Good, yeah.
basically then I just found 1% of the value given, 3100, which would be 31, and then multiplied by 2 to get 2%, which is 62, and then added all the values to.
Good, yeah. We can actually make it slightly simple using the same idea, because to find 7%, we can say that 1% is 37, and then 7% is then 31 times 7, which is going to be 217. So it's a similar idea. I just show another alternative for this. And so 57% is going to be your 50% plus the 7%. And that should say 57, I'm sorry. And of course, we get the same answer because the method doesn't matter. Okay, cool. So we have two methods here for multiplications. One of them was to find 1% and then multiply, and the other one was to split the 57% into different pieces as long as I can calculate each of the pieces. And so any method that's some combination of these is great. Okay, so that's everything I want to say about percentages. Percentages is basically multiplications again. I'm going to do, yeah, let's move on and do, I'm going to do square numbers next. A slight change from the plan. I'm going to do square numbers. So answers in the private chat. What would be 67 squared? Cool. A lot of answers here, some of them incorrect, but some of them, yeah, but some of them are great. So the correct answer here is 4,456. and 89. So congratulations to everyone who got that correct. Can we have some volunteers to share their methods? There's 3 methods that I want to share. Like Ashton from the Philippines has a good method, for example. And Arnav, so Ashton and Arnav are requesting to share, a few other people as well. So maybe invite one of these participants to explain their method, please. Avinav, is that possible?
Yes, Arnav and
Ashton.
Ashton. Rakat, can you do that?
Yes.
So who do we have mute by now? Is anyone mute? Ashton or Arnav?
They're not responding to the.
Okay, how about Naitik? How about Naitik Arora?
Yeah, Nathik or Anshka.
Can we have Naitik Arora unmuted? He's here and he's requesting for the same.
Hello.
Hello. Which method did you use for 4,489?
So actually first I took the square of 7, which is 49.
Okay.
Then just to the left of it, I wrote the square of 6, which is 36.
Okay.
Then I multiplied 6 times 7. Actually, after we just write both of them simultaneously, we get 3649. And then I took and then I multiplied 6 into 7, which is 42. And then I multiplied it by 2, which is 84.
Okay, nice. So this is, I'll do it in a slightly different order, but this is similar to the cross multiplication method.
Yes,
So
sir.
we think of this as being 67 times 67. So then we start with the 7 squares, which, as you said, that's 49. And then we've got the 6 times the 7. And then also the 7 times the 6. So this is exactly the same as we did in the multiplication section. We've seen the same technique appear for multiplication, for percentages, and also for the squares. So we get the 4 that we...
That's the carry.
Good, yeah. So you got the carry digit there. And then we add it to 6 plus 7. At this point, I want to make sure I have the correct answer because I'm going to forget. So that's 46. And then I add on the other 7 times 6. What can help is knowing that it's just the same thing doubled. So an alternative here, I can take this and say it's just the double of that.
Multiplied by 2.
Nice, yeah. So that there is going to be 7 times 6, 42, double it, 84. Add 4, that's going to give me 88. What do I do next?
So now we take the 8 carry and we like add it to 6 times 6.
Good, yeah. And I can't type, but what's the answer?
Then we'll get 36 plus 8, which will be 40, which will be, I think, 44.
Nice, yeah, good. It's 44. So
And
then the answer that we've written down is 44,
89.
8, and then we started with the 9. Very good, yeah. So this here is cross multiplication.
Thanks, sir.
Or crisscross, 2 different names for the same method. Okay, very good. Thank you for sharing. I'm going to show two different methods and 2 alternatives here. So another method is by memory. So if you memorize the squares up to 99 squared is equal to 901, then it's very easy because you don't have to do the calculation, you just know it from memory. And then there's also special squares where I change the 67 down to a 60. That's a decrease in 7. That's a decrease by 7. And then so I also increase 67 7 to get 74. So I'm changing 67 to any number that I want that's easy. So change 67 to an easy number, and that's multiplication by a 7. And then make the same change the other way. So if I decreased 67 to 60, then I have to add 7 to get to 74. The answer is there. What I get if I multiply these together, 60 times 74, and then I add the difference. So this is because I added and subtracted the 7. I have to add the square of 7 to the end. So this here is then going to be 440 plus 49, which is of course the same answer. So this is another method that works really well for squares. A few good questions here. Why can't we round up to 70? Yeah, we can do that as well. So let's see how that works. We can say 67, change it to 70. That there is plus 3. So then I'm going to do 67. I'm going to do the opposite now. I have to do the opposite to get 64. And then the answer is going to be 70 times 64. And then plus, in this case, the 3 squared. And that there's going to be 4480 plus 9. So yeah, there's an alternative method here that also you can round the 67 to anything you want. Best options are 60 and 70, as long as you adjust the other number the same amount in the opposite direction, and you add, it's always adding the correct square at the end. Can we do quotients and remainders? Yes, we do that soon. I don't understand the third one. That's fine, as long as one of these methods you understand. Which method do I think is fastest to use? I think the fastest is knowing it from memory, but then you have to spend some time learning them from memory. Otherwise, I think the special method for squares is the fastest, and the slowest is the other methods of multiplication, like we started with. So any more methods? We could find some other methods, but these are the 3 methods that I wanted to share. We're gonna do a couple of examples. I'll share a tool, and then we have a little break before we do the other topics that you requested. So answers in the private chat. What would be 83 squared using any method you like? I'll give you a tip. All 2-digit squares are 3 or 4 digits long. For example, 32 squared is 1024. And if it's a square of a number that's bigger than 32, then it has to be a 4-digit number. I give a moment more for everyone to finish with the answers. I see lots of correct answers. The first digit should be a 6. Okay, so the correct answer here is 6,889. So whichever method you tried here, the correct answer is 6,889. And if you need to use pen and paper, then feel free. If you can do it in your head, then that's better because it's faster. Let's try one other example. Let's try 75 squared. A few people guessing it's not 4,225, it's not 7,225, it's 5,000 and something. Cool, yeah, I see lots of methods here. Okay, cool. So the correct answer is 5,625. Can we invite Delvik? Delvik has a cool method to share. A few people have shared the same method, but can we have Delvik, for example, to show us the special trick for square numbers that end in 5?
Yeah.
Hello.
Good, yeah. So what trick did you use?
So the trick I use it that basically if any number has a basically two-digit number and the last digit of the number is a 5, then the very good trick is that first you multiply the last two digits, that is 5. So 5 into 5, that is 25. And that will be the last two digits. And suppose like the 75 is the number. So the first digit is 7 and we take a number above the 7, which is 8. And 8 into 7 is 56. So the answer is 5625.
Good, yes. The tens times the number above is 7 times 8, which is 56. And then just write 25, that's 5 squares after. This only works for squares that end in 5. So square numbers that end in 5 are the easiest because you can use the trick that Dalvik just shared. Thank you for that. You get the tens digit, you multiply it by the number above. So here the 7 we multiply by 8 to get 56. And then it's going to be just 25 afterwards. And the reason this works, it's the special method for squares, ends up simplifying to this rule. Okay, nice. So let's just do a summary of the squares methods. So you could use crisscross, or you can use the special method for squares. As a shortcuts, you could learn them from memory, and then just trick for squares ending in 5. So this is the important stuff to take away from this section with square numbers. Okay, so next thing I'm gonna yeah, I have yeah, so I mentioned here that it's useful to know the squares from memory because then you don't need to calculate them. There's other places where it's useful to have things memorized. So we're going to take a little break for a few minutes, but in the meantime, I'm going to give everybody a link to a special tool that I've made for people, for everyone preparing for the Mental Math World Cup to use. So I'm going to share my screen and just show you how this works. And then you can use this while we take a little break. Let's say this is for memorizing different types of mathematical facts that I need to know. So let's say I want to practice the times tables up to 9. If I select the times tables up to 9 here, then immediately it's going to give me a times table, and I just have to answer as quickly as I can. So I type the number and I press enter to say that I've done it. And then when I want the next question, I press enter to see the next one. So 14. And I press enter as fast as I can. So I try to do this as quickly as I can. And at the end, it's going to tell me how many questions I can do in 30 seconds. If I make a mistake, it's going to tell me at the end. So 3 times 5, I got this one wrong. And let's say if there's any that's really slow, then it's going to tell me that as well at the end. So the challenge is to see if anyone can get a higher score than I have here. Okay, so I have a score of 28 with this, and I'd like to see if anyone can have a higher score on any of these categories here: doubles, triples, cubes, and the times tables up to 12. We're going to take a quick break, and we will come back in 6 minutes' time.
Yes, and Daniel, would you be putting that link on the chat for everyone?
Yeah, I'm just typing it in here. So the meeting group chat for everyone. This is the link you can use to try that tool.
Come on, everyone. I'm sure we'll have a lot of people trying to beat Daniel.
Okay, and we take a break now for 5 minutes. Yeah. So when it is like 35 past the hour in most countries, or 5 minutes past the hour in India, then we start, or 20 past the hour in Nepal, then we start.
Yes, yes. Everyone, 5 minutes, please come back on time.
Okay, let's slowly start again.
So did we have anyone beating your score?
Yeah, so if you've got a score, whether it's a good score or a bad score, then let me know in the private chats. I can see there's about 90 people. Yeah, I can see there's about 90 people who've been trying it. So answer of 20 is pretty good. Answers of 25 to 30, those are really high. I see some people are getting scores 23, 30, 18, 32. I think 32 is faster than I get. I think my maximum was 31. So good job. 28, 34 even. Yeah, some very, very fast people here. Really good. A few people who maybe arrived at a different time and didn't have the link. So the thing everyone is talking about is this link here. Okay, really nice. And I'll have some other tools like this that you can try in a moment. Let's get started then with a new method. Let's do something a bit different. Let's do the cube root. These are ones that seem really difficult, but they're actually very easy. At least cube roots of numbers up to 6 digits or up to 7 digits even are very easy. So the first thing is for the idea of cube roots, this is exact cube roots, is that, I can't type. We know that some number cubed is equal to something, find x. So we know that there's some number cubed, which is the number that we're given, and we have to find that missing number. So an example, if I said that cube root of 8 the answer is 2, because 2 cubed equals 8. And of course, 2 cubed means 2 times 2 and times another 2. So we have 2 multiplied by itself, a total of 3 times. So in order to the type of question that we're needing to solve for the cube roots is things like the cube roots of 830,584. So if you have the answer, type it in the chat. And if you don't know how to do it, I will show you one of the easiest methods today for solving this. Okay, yeah, quite a lot of incorrect answers as well. I have a few incorrect ones. Okay, so this is maybe new for people here. Okay, so could I have a volunteer? Maybe Jaden. Jaden, you were the fastest with the correct answer. Would you like to share the method that you used for this? Are we able to get Jaden? Jayden? Or maybe Yuvia?
Can we have a Jaden?
Okay.
Jaden or Yuvia?
Yeah, we have Jaden or Yuvia. Could we unmute one of them and invite them to explain how they got the correct answer.
So basically, as you know, that the cube roots between 830 are 729, okay, and 1000, which means 9 cubed and 10 cubed. So you basically, since it comes between 9 cubed and 10 cubed, you put 9 first. 9, okay? 9,
Okay,
then
yeah.
you put this 4. Between 9 and 10.
Yep.
So, and then 4 times 4 times 4, meaning 4 times 4 is 6. Take the last digit, meaning 4. 4 times 4 is 6 at the end, and 6 times 4 at the end is 4 again. So obviously we combine 9 and 4, what do you get? 94.
Good, yeah. So this is exactly how we can do it. We can look at the units digit, which is a 4, and that tells us what the first digit is. And I'll explain how to do this in a moment. So the answer has units digits 4. And so if the question begins with a 9 and it ends in a 4, then the answer must be 94. So cool. Thank you very much for sharing. That is correct. And I'll explain in a bit more detail the exact steps that anyone can do to solve these cube roots. So the first thing is you need to know these cube numbers here, and maybe I'll put 10 cubed here as well, just to be complete. So the first thing you do when solving any of these questions, I'll take the same example. So for 830,584, I'm going to split the right 3 digits, and it's always 3 digits. So that then looks like 830, and then I've split off the 584. So then you look at the last digit, which is 4, and check the table. So if you look at the text in green, notice that, so what I've done is I've got the number, the cube of that number. For example, 9 cubed is 729, or 4 cubed is 64, and I've written in brackets the last digit of that number. And notice, if you look at these, that every digit appears only one time. So the only time that 4 is the last digit is for 4 cubed. The only time that 7 is the last digit is for 3 cubed. The only time that 3 is the last digit is for 7 cubed. And this means that if I know the last digit of the cube number, I always know the last digit of the answer immediately. And for most of them, it's easy because it's the same digit. And in this example, the last digit of 830,584 is a 4. And the table tells us that if the number and if the cube ends in a 4, then the answer must also end in a 4. So checking at the table, this tells us then answer ends in 4. So look at the part that's not split off. In this case, it's 830. Compare with the cube numbers. In this case, we get the answer is in the 90s. And therefore the answer has to be 94. And this method always works simply like this for any 2-digit cube number. And in the future, if you want to calculate cube roots of larger numbers, maybe 10-digit numbers, even 12-digit numbers, then there's a more advanced version of this method that you can use. So the starting point is to use this method here. So it is, yeah, do we always take questions here? Do we always take the first 3 numbers? No, we look at the right of the number and we take away those 3 digits. So it's always the 584 that we take away, and then we look at the remainder. What about square root? That's different. We're looking at cube roots at the moment because cube roots are easier, actually. Let's take another example and then try to use the same methods that we've looked at just now. I'd like to know what is the, yeah, that's a good example. So what is the cube root of this number? I'm trying to write it. Oops. So the cube root of 54,872. So be careful here. I'll give you a clue. The answer is less than 70. The answer should be less than 70. So while you're answering, I'll start off. So we split the last three to the right three digits. So it's 54 and then 872. So the last digit is a 2. So the answer ends in, what does the last answer end in? And then where is 54 in the list of cubes? Okay, can I invite Tanvi? Can we unmute Tanvi and to hear how we get the answer?
Tanvi?
Yeah, could you please share how, yeah, can Tanvi? Can you please share how you got the answer? I think you had a good methods.
Okay, can we have Tanvi unmuted?
Can you spell, please?
Tanv.
Tanvi.
Okay, so can I answer? Yes.
Sure, yes, please.
Yeah. So we divided by in three parts. So the last number is 2. So it's going to be the last digit is going to be 8. And
Good,
the
yeah.
other three numbers, like it's 5, 4, 8. So we're going to find the closest number. So that is going to be so that is
So
going to be
54
3.
appears between 27 and 64. Yeah, exactly.
So it's 3.
Good, yeah. So 10's digit is 3. And so what's the final answer? Final answer then is, yeah, 38. Cool. Thank you very much. And so a few incorrect answers were coming in here. So some people had 42 or 32. The answer doesn't end in a 2. So the cube, 54,872, ends in a 2. And if we look at the list of cube numbers in green, then we find that the only number sorry, wrong place. The only cube that ends in a 2 is 8 cubed. And that tells us that even though the cube ends in a 2, the answer must end in an 8. So we know the answer ends in an 8, not a 2. And then we look at the tens. So for the tens, we find that 54,000, the 54 is between the 27 and the 64. So that means it must be more than 30, but less than 40. So it has to be in the 30s. So we know it's a number in the 30s that ends in an 8. So of course it is 38. I think we should do maybe a couple more examples of these. This method, I think, is more new than the other things that we've done. A question, what if there is a remainder? Yeah, good question. For these ones, there will never be a remainder. So for the exact cube roots, which is all of the cube root questions in the Mental Math World Cup, there will never be a remainder. So it's guaranteed to have an answer. So let's try some other ones. So we don't have to memorize them. I've got the cube numbers here again. So these are ones that are useful to know from memory. And I'd like to know what would be yeah, that's a good one. What is going to be the cube root of 32,768? Good, yeah. This time I see lots and lots of correct answers, lots and lots of correct answers, which is really nice.
Daniel, the second step, the first step, split the last 3 digits, 32, 67.
Oh, thank you. Yes.
Yeah.
Thank you. Yeah, sure. Can we have Nitik Aurora? Nitik, N-I-N-A-I-T-I-K, to volunteer to give us the answer.
Sir, can you hear me?
Yes, we can hear you well. Thank you.
Sir, so now we split the digits. So from right, we take 3 digits, which is 768.
Yeah.
And the last digit is 8, which we get from 2 cube, which is 8. So the last digit will be 8.
Nice, yeah.
Then the 32, we have 32, which lies between the cube roots of 3 and 4, which are 27 and 64. So the less one is 27, which will be 3. So the answer, the 10th digit will be 3. So the
Really
answer
good, yeah.
will be 38.
32, but you said yeah.
Yes,
32.
You said everything else right, yeah. Exactly,
Yes.
yeah. This
Sorry,
is exactly right. No worries, yeah. Thank you very much, yeah. So this is exactly right. We're splitting the 3 digits from the end of the number, and that is so that we're looking at the correct tens. So if you got an answer of 62 or 68, that's not correct. It's because you didn't split the number correctly. And if your answer didn't end in a 2, then you didn't get the correct ending digit from the table. But I see this time we had mostly correct answers there, which is really good.
Daniel, on line 4, yes, that's right.
Yeah, cool. Thank you, Anav and Avinash. That's a typo. Really good. Let's do one more example like this, and then I'll show you. Yeah, let's do one more example like this. So let's do the cube root of this number, 205,397. I see lots of correct answers coming in, so good job. The answer is 59. And I'm just filling out the explanation here. So 205 lies between 125, which is 5 cubed, and 216, which is 6 cubed. Oops, got the character there. So the answer is in the 50s. So the answer is 59. Okay, really good. So with a little bit of practice, these cube roots are super fast to solve. And I'll show you later a way that you can practice those. If you didn't understand the methods, then take a look at the whiteboards afterwards, and we can hopefully the method is going to be easier then. I want to have an explanation on my website as well, but I haven't yet written it. But hopefully what's on the whiteboard here is fine. Question: how do you know that it is 59 and not 69? It's got to be, it's less than like 60 cubed would be 216 with zeros at the end. And we know it's less than that. 205 is less than 216. So it's less than 60. It has to be in the 50s. Hopefully that helps. Okay, so that's everything with that's everything with cube roots. And so if you want to do cube roots of larger numbers, there's more advanced techniques that can help with that, but we're not going to cover them today because it's too much. Question: how do you know that the ending digit is a 9? Look at the green text. So the cube numbers all end in different digits, and the only one that ends in a 9 is 9 cubed. And that tells us that the answer must also end in 9 cubed. I have another few questions coming in, but they're mostly repetitions of things I've already answered. So I think I have to stop there.
Yes,
It
that's
would the but I have a way to practice this as well. So I'm just gonna share a tool here. Again, I'll give you the link to this tool. Question: if the cube has more than 6 digits, yeah, you split in many groups of 3 starting from the right if you're doing more advanced ones. So this is a tool for practicing exact cube roots of different sizes. So if you want to practice knowing the cube numbers, then you can try 1 digit. What we're doing today is 2 digits. And if you become more advanced, you can try this for 3 digits, 4 digits, or even 5 digits. I will show you how this works for 2 digits. So as soon as I press the 2, it's going to give me the first question. And so here, I think the answer begins with an 8 and ends in a 6. Begins with a 9, ends in a 2. We had that. Oh, sorry, ends in a 4. My mistake. This here is 12 from memory. This here begins in a 6, ends in a 5. Begins with a 7, ends in a 5. So you see how fast I'm doing these. You can do it at this kind of speed as well. I'm busy talking at the same time. It doesn't matter because the method with practice is very easy. So the way this one works is different to the flashcards tool that I showed you earlier. You just keep going as many questions as you like. So here I did 10 questions, and it tells you how many you got correct. Obviously, when you're in the Mental Math World Cup, you don't want to be making mistakes because then you could be losing marks. So you can be losing 2 marks for every question you get incorrect. And that also means you're not getting the 10 marks for having the correct answer. So you really want to make sure that you're accurate. That's more important than rushing too much. And also this tells you how quickly you're solving them. So I'm answering these ones in 2.3 seconds. And if I wasn't talking at the same time, maybe I would get faster. It's not important if at the moment you're not answering so quickly. Maybe it's taking you 10 seconds or 20 seconds, especially if you haven't memorized the cube numbers yet. So once you've learned the technique well, then you can use this. If you're taking only a few seconds to solve the questions, then you've become very fast with that. The other thing I want to share related to this, yes, is I already showed you the flashcards tool with, for example, the times tables. This also has some other useful types of category, and one of them is the cube numbers. And so this has the cube numbers not just to 9 cubes, but up to 15 cubes. So you can practice with this as well to see if you know the first cube numbers. And this is then really useful shortcuts for when you're doing these exact cubes, because you don't have to think too hard what the cube numbers are. They're already very easily in your memory. So you can also use this to check whether you know the cubes. So I'm going to give a link to the cube roots tool. The website is World Mental Calculation. It's my website. A good question from Sana Anjum. I'll give this question to Avinash perhaps. So what's the most difficult cube roots that people will have to do in the Mental Math World Cup?
5 digits, 5-digit cube roots.
5-digit cube roots.
Yes.
Okay, so that's the answer here. So the method that I showed today is sufficient for solving these, and it also works for 6 digits very easily. So I'll give a few moments so you can try using these tools to answer a few questions, and then we're going to finish the workshop today by looking in a couple of minutes at divisions. Meanwhile, I'll just look at some of the questions. So how to do 5 digits cube roots? It's the same thing. So I presume, Avinash, when you say 5-digit cube roots, you mean the question is 5 digits and the answer would be 2 digits.
Yes. The question is 5 digits and the answer will be cube in 2 digits.
Cool, thank you. So we already did 2 examples like this today, and then we did 6 digits, which is actually not harder. It's the same difficulty when it's 6 digits in the question. Yes. It becomes harder when you have 7 digits. Then it's useful to know a few extra cube numbers. 8 digits and 9 digits, you have to do a division step or to memorize some extra tables. For 10 digits to 12 digits, you need to do both of those things or get very good with the division technique. And the more digits you get, the more different techniques you need to combine. But for the Mental Math World Cup, it's just what we did today. Simple as this.
And as I've already mentioned, the recording for this will be available for you all from tomorrow onwards. You can go back and go through this topics. You can keep repeating them until you understand. As Daniel has just mentioned, the cubing of 1 to 9 is extremely important to be able to solve the cube root sum. So you need to by heart and these cubes. And if you have that taken care of, then you'll be able to solve the cube root sums very easily.
And so this is, when people learn to do it, this is maybe their favorite type of mental math, because it looks very complicated, but in practice, you can solve the questions in 2 or 3 seconds. Yeah. So I can see quite a few people are trying the tool at the moment. I'll let you play with that for a couple more minutes, and then we will look at divisions. I get lots of questions in the private chat of Zoom here. If I see you're answering the same, if I see you're sending me the same question lots of times, then I'm going to ignore. Sorry. Question for Avinash, just while we're here. I am not able to save the whiteboards from my interface. When I'm the main host, I can, but from here I can't. Are you able to save the whiteboard maybe now and then maybe again at the end?
Yeah, Prakyat, can you do that?
Thank you.
Prakyat,
Yeah,
would you be able to save the whiteboards?
I won't be able to save the whiteboard from my end.
So as an admin, you would not have. So can you give access to Daniel to save it?
Yeah, I'm seeing if there's another way that I have that. Try again.
There seems to be an issue over here with the whiteboard then. Prakyat, you're sure, right? There's no way to save this?
Because I think
Yeah.
we are using a classic version of the whiteboard. The one that can be saved is the new version.
Okay. Yeah, we have an idea from Niantic that we can just take screenshots at the end, and at least we've got a photo of them all. That also works. Just take a screenshot after the end of the workshop. And anyway, it's going to be on the recording.
Yeah, it is under recording, so that's it's always going to be there.
Okay, nice. So a few people have sent me their scores through here. 49 out of 50 questions, 98% accuracy. Cool, well done, Pareshi. Clearly you're very fast if you manage to solve 50 questions in that time. Really good. Okay, so let's move on then from cube roots and have a look at the division method. And if time, we can look briefly at LCM and HCF. So I'm going to skip the easy part of division and move straight on to the more difficult part. And I'll just give an example of how I would deal with these things. So let's do 345 divided by 40. No need to give me the answers. This is an easy question. So the answer is going to be 8, remainder 25. So the first thing I'm going to mention here is the names of the different parts of the calculation. So this is called a dividend. The dividend is what we're dividing. The number we're dividing by is the divisor. And then the answer is the quotient. And at the end, we have the remainder. So we divide the dividend by the divisor to get the quotient, and there may be a remainder. So in the Mental Math World Cup, you have some questions that ask you to find where there's no remainder, and you just need to find the quotients. And there's other questions where you will need to find the remainder. And the easiest method for this, for easy questions, is just to take multiples of the divisor. So my thinking for this one is, you can see from the options the size of the number. So it's obvious here it's going to be 1 digit. So we say 40 times 8 is going to be 320. And then 345 take away 320 is equal to the 25. That's the remainder. So how did I get this? I had to look at the 4 times table. The 4 times table, and then here I'm looking for 4 times what is about 34. And I see it's just over 32. So I realize, yes, okay. So 40 times 8 is 320. The answer is going to be just over, just over 8. Questions about what happens during the test is multiple choice. So you will see what the correct format is of the answers in each question. So if this part is difficult for you, then practice doing simple questions with divisions by easy numbers like this. What I want to show you today is what happens when you divide by larger numbers. So question for everybody, very similar question to what we just did actually. I want to know what happens if I do 345 and I divide that by 41. What do I get? What's the quotient and what's the remainder? Okay, so a lot of correct answers coming in. The answer is 8, remainder 17. And two methods. One of them is we can just multiply 41 by 8 and find the remainder. Yeah, we could do 41 times 8 and find the remainder. I'm going to show you an alternative with the flag method. So for this here, so we look at the divisor. So with 41, the flag, let's say the flag is the 1 and the stem is the 40. So we're thinking of 41 as being like 40, but actually it's one more, and we call the flag this 1. So then what we do is we can divide by 40, first of all. 345 divided by 40 equals 8, remainder 25. But then we consider the flag as well. So because we're finding multiples of 8, 8 times 40 is going to be 8 times 40 we know is 320. 8 times 41 is going to be 8 more than that, so the remainder needs to be 8 less. So therefore, the remainder is going to be 8 less. 25 remainder 8 is equal to 17. So this is a method. If you don't want to do 41 times 8, you can use this flag method here, where you get the remainder and adjust it. I don't want to go into too much detail on this, because most of the examples you have in the Mental Math World Cup are quite easy. But for the advanced students, you can use this method here. So, question. So just a summary before I go on. You take the quotient, you say that it is like an easy number that you can do division by. So we can say it's, in this case, it's like 40. In that case, you say that you do the division by 40, but use a flag of 1. And then when you do the division by 40, you then have to adjust it afterwards by the flag multiplied by the quotient. So flag multiplied by quotient is 1 multiplied by 8, which is 8. Because flag is positive, plus 1, we remove the minus 8 from the remainder. So this is a more advanced method for division called the flag method.
I think in our we do have both perfect divisions as sums as well as the remainder. So this flag method really helps in getting the remainders quickly.
Yeah, and so let's try another example, very similar. So if I tell you that 345 divided by 40 is 8 remainder 25, what would be 345 divided by 42? The remainder is then going to be 25, take away whatever 2 times 8 is, and a lot of people have answered, this is then going to be 9. Cool, good. I think this method is quite a difficult method. This is one of the more advanced things in this workshop, and we don't have too much time for it, but we have, yeah, I've got lots of correct answers and some explanations as well. Cool, really nice. Let's
So I
try
think
one.
this is a great method, Daniel. So this should help with the remainder topic for the kids. This will be very helpful.
Yeah, thank you. And if anyone who finds this difficult, if you can understand this, this will help you a lot for the remainders. So let's try another one. Let's try 678 and divide that by 80. So 678 divided by 80. Very good. I have lots of correct answers, a couple of mistakes, but mostly people have that the answer is 8, remainder 38. So the quotient is 8 and the flag is 0. Now let's try another question. What's 678 divided by 83? Remember, the quotient is 8 and the flag is 3. Cool, yeah, I'm getting lots of correct answers. This is good. Can we have a volunteer to explain how they got the correct answer? Maybe Aksh, AKSH, Aksh Sharma. Is it possible we can unmute Aksh Sharma?
Yes, sir.
Cool. So how did you solve this one using the flag method?
So first I did 678 divided by 80 as a whole, and that would be 8 because it is the nearest to 678, that is 640. So after I did that, I multiplied by 8. So that is 24, and then I subtracted 38 from I subtracted 24 from 38.
Really good, yeah, that's exactly right. So we've got 38, which is the remainder if we were dividing by 80, which is not the question. And then we say, well, okay, fine. The flag is 3, so we need to multiply the flag by the quotient and then subtract that from the wrong remainder that we started with. So that's 38, take away 24, and then, as you said, exactly right, we have the remainder of 14. So the answer is 8 remainder 14. If the question is the asking for the remainder, the answer is just 14. Question, what do we mean by the word flag? Well, in the divisor with 83, we're doing division by 80 because division by 80 is easy, but 83 is not 80. It's a little more than 80. It's 3 more than 80. 3 is the flag. So you can think of it as a big round number plus the flag. Let's try a couple more examples of this. I need a different whiteboard. Here we go. So first question, kind of easy. What would be 400 and yeah, let's do 479 and divide that by 80. A question from Ayan, the answer is yes. We do that next. Okay, really good. Yep. So the answer is 5 remainder 79. New question. What would be 479 divided by, let's do, yeah, divided by 87. Okay, a lot of answers, not all of them the same, but the most common answer we're getting is 44. Yes, that is correct. And the way we do that at this stage is we get the 79 remainder, which is wrong. We do the 79 and we take away whatever the quotient times the flag is. And quotient times the flag, of course, in this case is 35. And 79 take away 35 gives us 44. So the answer is 5 remainder 44. So well done for everyone who got that. This method is the more advanced division method. So if it's difficult, have a look at the whiteboards or the recording later, and hopefully that will help. Next question. Let's do something very similar, and we'll come across, like, there's two little tricks we can do. So first of all, what is 480? No, let's do 481 divided by 80. Question, would the quotient be given? No, you have to calculate the quotients. So good. So a lot of people coming in with the answer 6 remainder 1. This is correct. This is correct. And now what would happen if I did 481 divided by 87? the quotient is 6, flag is 7. So then I have to do 1, take away 6 times 7, which is 42, which is negative 41. This doesn't make any sense. This has gone wrong. Because the remainder is really small, I can't take away the quotient times the flag. It's not going to work. So some people are saying, yeah, we can't do this with remainder 61. So no. So we need to use a heavy remainder. So this is where I use a different quotient with the corresponding remainder, where the remainder is larger than 80. So I use a remainder that's too large. It can't be the answer to the question. It's I call it a heavy remainder, and this is going to help us solve it. So I say 841 divided by 80 is like 5 remainder 81. This is the heavy remainder. So then when I do 481 divided by 87, I can use that heavy remainder. So the quotient, I'm now going to use 5. The flag is still going to be 7. And then I do the heavy remainder of 81, take away 5 times 7, which we know is 35. And that gets me the answer. Many people have said it is 46. So the only difference here is rather than using the correct remainder for the division by 80, we use an extra large one. A question, for us to figure this out, it will waste a lot of time. Yeah, unfortunately, with divisions and also with very advanced square roots, you have this problem sometimes that you make a guess and it turns out to be incorrect and you go back afterwards and change. So let's do another question where you'll have to use the heavy remainder. So what would be 275 divided by 90, divided by 94? Good, yeah. And maybe we can have a volunteer. Can someone just type me yes in the chat if you had the correct answer to remainder 87 and you want to explain how to use a heavy remainder to solve this question? So someone type yes in the chat if you'd like to explain how to do this. Okay, maybe we can have maybe Devansh. We have Devansh Singh Gujja, please. Devansh. Avinash, can we unmute the Devansh, please, so that he can explain?
We're unmuting, but he's not accepting the request.
Okay. Yeah, Devansh, could you? We've allowed you to speak. If not, maybe we can have Arnav Sharma from India.
Hello.
Yeah. So how would you use the heavy remainder? for solving this?
So first we'll take it as 90 and then we use the heavy remainder. So instead of using getting the quotient 3, we'll use 2. So which is
Good, yeah.
18. So
So this
27
could
minus
be
8,
H remainder 3, 5
Yeah.
too small. So
Yes. So
we
we'll
don't
use
do
2
that.
instead of 3. We'll
Very
get
good.
we'll get 95 as a remainder, and then we'll multiply 2 with 4, that's 8, and then we'll subtract 95 from 8, that's 2 remainder 87.
Really good, yeah. Thank you very much. So the quotient here is 2. The flag is 4. So then we do the 95, the heavy remainder, take away 2 times 4, and that gives us then 87 as the answer. So the answer is going to be 2 remainder 87. Cool, very good. So this is the method I recommend for doing for solving these. And there are other methods you can use, but the reason I recommend this is because if you do more advanced mental maths things later, like inexact cube roots and square roots to many decimal places, divisions by very large numbers, then something like this flag method is the easiest way of doing it. The last thing, we're at the end of the workshop about now, but I just want to address the an alternative to this, and then I think we wrap everything up. And that is that you can have a negative flag. You can choose to use a negative flag. So in this case, if I do 275 remainder 94, I can take I can choose the divisor to be 100 and flag to be -6, because 94 is 100 take away 6. And so 275 divided by 100 is equal to 2 remainder 75. And so 275 divided by 94 is going to be 75. Take away -6, because that's the flag, times the quotient of 2. And that's just another way of saying 75 plus 6 times 2, which is 12. And that's going to give us the same answer. Like this. So this is how you can use a negative remainder for solving the question. Last question of this workshop before we have to finish. I'll give you a question where you can use a negative flag. So this question is going to be 567 divided by 98. Cool. Lots of good answers here. Yeah, lots of correct answers. Very nice. So the answer is 5 remainder. Be careful that we need to add on the because the flag is negative, we end up adding. So the answer is actually going to be 5 remainder 77, not 57, 77. Can I have a last volunteer for today to explain how they got the answer of 5 remainder 77 using a negative flag? There are other methods, but I want to hear about negative flag. Maybe, yeah, let's finish with Abdelrahman Salah. please.
Hello.
Hello, yeah.
First, well, change the advisor to 100.
Okay,
Will
yeah.
be minus 2.
So the divisor is 100, flag is -2. Nice.
Yes. Then we
So we cannot hear you well. I think we've lost the audio, but this is the correct start. So I would do 567 divided by 100, be 5 remainder 67. Do we hear you again? No, I think not, unfortunately. Okay, so 5 remainder 67, and then the 567 remainder 97 has remainder 67 plus, because the flag is negative, so we have to use plus 2 times 5. That's 10, of course, and that there is 77. So the answer is 5 remainder 77. Okay, so there's a lot of content today. Well done for paying attention for a workshop of more than 2 hours with lots of the advanced techniques. Some of this was very easy for some of you. Some of this was very new and fast. So I recommend to have a look at the methods afterwards and think of this as an introduction to these methods. Anything you want to mention at this stage before I just leave the last couple of resources?
Yeah, Daniel, thank you so much. I think we've covered a lot today, and these are definitely going to be very helpful. I would have wanted to also cover on, touch upon LCM and HCF, but I guess we don't have.
I mean, if you like, I can do that. Like anyone who wants to leave can leave, and I can spend 15 minutes on HCF and LCM just now to finich off. And then for square roots, I just have a tool and nothing else to say on that, but only if we have time. Maybe we don't.
Sure. I see. I would leave it open to the audience. If somebody wants to leave the session, you're free to do so. But
yes,
Mr. Timms is here, and he will be touching upon the HCF and LCM part. So I think you should make use of it.
Yeah. Just before everyone leaves, before we do that, the last thing I want to mention is that if you're interested in the how to solve the cross multiplication method, I have a link here on the chat to something that I've written that explains how to do the multiplications. So this is the first topic we did today, the cross multiplications. This is an explanation of how to do that for even larger numbers. So if you didn't understand today, or you want to understand how to do it with even larger numbers, then that resource can be useful for you. And for square roots, we didn't say much about the square roots today, but if you know the square numbers and you can solve them, then you can also use something like the cube roots method. And this here is a tool you can use for practicing the square roots. I think the largest ones we have in the Mental Math World Cup are 5 digits. So that means you should, and the tool, use the setting of 3-digit answers is the thing that is worthwhile to use. And yeah, I think that's, and if you find that the method, you understand the methods well, but actually doing them is difficult, then that's just a case of practicing. So I'll do an extra 10-15 minutes about highest common factors and lowest common multiples at the end, because I had lots of people asking for that actually. But otherwise, if you don't want to stay for that, then I think now is a good time to leave. This is the main part of the workshop is over. Thank you for listening. Thank you for paying attention and for sending your answers in the chat. And good luck for when you compete in the mental calculation, in the mental math World Cup.
I think most of us
Just
would be staying back. So you know, I'm sure.
but just a bonus. Okay, so HCF and LCM, these can be quite difficult, but the answers in the mental math, the questions in the Mental Math World Cup are not very difficult. So we don't need to do very advanced techniques to get the answer, especially because the questions are multiple choice. So I'll start off with a definition of those. So HCF means the highest common factor, and it's also sometimes known as greatest common divisor. I'm going to use HCF because that's what it's called in the Mental Math World Cup, and that's how I learned it at school. The other one, LCM, this means the lowest or least common multiple. And so what does this mean? Highest common factor means the largest number that divides into both numbers or all numbers. So let's take an example of this so we know what we're talking about. Let's say we have a question that says find the LCM. So find the HCF of 45 and 63. So this means which number is the largest number that divides into both 45 and 63. That's what the question is really asking. What's the largest number that divides into both of those? Yeah, a lot of people answering the question. So some people are answering 3. So 3 is a common factor. 3 is a common factor, but it's not the highest one. 3 is a common factor because if I do 45 divided by 3, has no remainder, and also 63 divided by 3 also has no remainder. But is there a larger number that divides into both of them? Yes, 9 is the highest common factor, because again, the divisions for both of these work exactly, and it's the largest number for which this is true. So this is the explanation for the highest common factor. What about for the lowest common multiple? And then we'll talk about some methods for actually finding these once we understand what these things mean. So find the lowest common multiple of 45 and 63. So what would that be?
Right. It is multiple good numbers. Sorry, it's not, I don't know how to calculate that. It takes a long time, that's why.
So 285 is a common multiple. In fact, let's make a bigger one. 28,350 is a common multiple because 28350 is equal to 445 times 630. And also it's also a multiple of 63. It's a multiple of both numbers, but it's not the lowest. There is a lower one. And a lot of people have told me the answer that, yeah, it's 315. Because that's the lowest one. It's not the lowest. 315 is the lowest common multiple. So the lowest number that is a multiple of both 45 and 63. And just a few facts that are useful to know before we try solving some of these. One of them is that the highest common factor multiplied by the lowest common multiple equals product of both numbers. Example, if I do 45 multiplied by 63, I get 2,835. If I do the highest common factor multiplied by the lowest common multiple, then this gives me 9 multiplied by 315, which is the same number. So this is a cool maths fact that might help you. So there's the theory. The next thing then is how do we solve those in practice? So I'll get another question here, and then I'll ask you to solve it, and I'll ask someone to explain their methods that they're using. So the highest common factor of, let's do 72 and 88. Okay, and can we have Lim from Malaysia? To explain how they knew the answer. So Lim from Malaysia. Please.
Hi.
Hello. How did you know what the answer was? You had it correct.
Oh, I'm pretty surprised that I got it correct, but how I did it was pretty simple. I just used the number that I thought was the highest 2 times to get 72, which is 8 times 9. And then for 88, I use 8 times 11. So both of the numbers that are the same in both are 8. So that's how I got my answer.
Nice, yeah. And this might not seem like much of a method, but this is the easiest way of finding the highest common factors. So you simply look at which times tables both numbers are in. And so as Lim said, 72 is in the 8 times table, and also 88. So the 8 times table contains 88. And so once you know this, then you know that 8 is a common factor. 8 is a common factor of these two numbers. And then you just have to say, well, can I find a higher one? And in this case, no, there's not, because 72 is equal to 8 times 9, and 88 is equal to 8 times 11. If there was a highest common factor, it must be a factor of both 9 and 11, and there's obviously no number that divides into both 9 and 11 except for 1. So yeah, so that is going to be the final answer. So yeah, very good. This is the easiest way of doing it. There's other methods that involve prime factorizing both numbers and comparing them, but for most questions that you get, this here is the easiest way. I'm going to show a little shortcut that can help with this. That if you subtract them from each other, a little trick here, find the difference between the two numbers. So in this case, 88 take away 72 is equal to 16. And then the HCF of 88 and 72 is equal to the highest common factor of 72 and 16. So if the numbers are very close to together, and often in the Mental Math World Cup, you are given two numbers that are close to each other, you can just find the difference between them and then solve for the highest common factor between those numbers. And so in this case, which times table is 72 and 16 in? Well, as Lim, using a similar method to Lim, they're both in the 8 times table. So, and we have 8 times 2, 8 times 9. So 8 is a common factor. 16 is not going to work. So we're left with 8. So I'll give you another question, a really difficult highest common factor question where you can use this method as well. So find the highest common factor. Highest common factor of, let's do 988. Is that what I mean? Yeah, 988 and 1014. No, this is wrong. No, I want to change it. Change my question. Highest common factor of 975 and 1001. So this looks like a really difficult question, but try using the difference trick. Okay, nice. I have not so many answers actually. So well done if you got the correct answer here. Yeah. So the correct answer is 13. Good job for everyone who got 13. Someone who got 13, can you volunteer to explain how you use the difference trick? Sure, Nitik. Nitik, N-A-I-T-I-K, to explain how to use the difference trick. Can we unmute Nitik? Yeah, cool, thank you. How did you use the difference trick?
First, we will get the difference of the numbers. That is, we get 26. And now we find the HCF of 975 and 26. And we'll see they have the common divisors 13.
Good, yeah. So the highest common factor of, let's say, 975 and 26 must be a divisor of 26. And Nitik, what are the divisors of 26? Or debuted, so it could be 26, 13, 2, or 1. can't be 26, but because the numbers are odd, so clearly 26 is not a divisor of 1001. That's not going to work, but can be, but 13 divides into 1001, therefore it's the answer. So this is a trick where you can combine what Lim explains about looking in the times tables with this idea of finding the difference between the numbers to make it easier, and that there is a faster alternative than doing the prime factorization. Finding the highest common factor is maybe easier than finding the lowest common multiple. So if you've got two large numbers and it's not obvious just by looking at the numbers what the lowest common multiple is, you can have a look at you can use the trick in green here to multiply the numbers together and then divide by the highest common factor. And the easiest way of doing this is to divide, so the method here is divide 1 by the highest common factor. LCM is that, then multiply by the other number to get the lowest common multiple. So an example of this, and then this is the end of the workshop. By now, this is the last trick that I'm giving you. So the example is for the lowest common multiple of 45 and 63. We say the highest common factor is 9. 45 divided by 9 is equal to 5. And then we do 63 multiplied by 5 to give us 315. And this is the lowest common multiple. So that there is a shortcut for kind of easy examples of highest common factors and lowest common multiples to get the answer. Cool. I think I'm done with that. Maybe let's finish. Should we finish with an example of lowest common multiple, or should we finish?
I think it's been a wonderful session. If you want to do one more example, I will not be complaining about it. So if you can take that, otherwise, even if you want to go ahead and finish this session, we are fine with that. But it's been a wonderful session till now, so I'm sure everybody really loves what you've done today for us. But yeah, I'll leave it up to you. One more example, and then we can move out here.
Yeah, so messages in the chat, people asking for another LCM. So we'll do one LCM, and then that will be the end of the workshop today. Then I've covered more or less everything that I wanted. So let's find the LCM of, let's try, let's say 105 and 110. So the LCM of 105 and 110. This is a difficult one. It's the highest common factor, yes, but we were looking for the lowest common multiple. So your number should be more than 110. So it's the lowest common multiple. Yeah, nice. I've got quite a few correct answers. It should be a 4-digit number. If it's not a 4-digit number that you wrote, then maybe check the answer. If your answer ends in 2 zeros, it should just be 1 0. Okay, nice. So the correct answer is 2,310. And can I have the last volunteer to explain how they got 2,310 as the correct answer? So just say one time. Okay, so Arnav. Can we have Arnav, please? Arnav Roy Biswas from India.
Hello, can you hear me?
Yeah, we can hear you. Thank you.
Okay, so first I found out the LCM of 105 and 110. So I used the difference trick. So since the difference is 5, so the highest common factor between 105 and 110 is 5. Then after that, I divided 105 by 5, which is 20.
Yeah, so at this point, we have to check, is 5 really a factor of 105? We need to check that, and it is, yeah.
Yeah.
Good. Okay, and then yes.
So
Very good so far.
I divided 105 by 5 and I got 21. Then I multiplied 21 by 110 and I got 2310.
Very nice, yeah, perfect. This is I'm very pleased you had that, because this is exactly how I would recommend to do this method. We find the highest common factor. These are big numbers, but they're close together. So we find the difference. What's the highest common factor of 5 and 105? Well, 5 is a factor of 105. So that's the answer. Job done. And then the lowest common multiple is what we get by multiplying the numbers together and dividing by the highest common factor. Because the highest common factor is a common factor, we can clearly just divide either number by that. So I did the same thing. 105 divided by 5 is 21, and then multiply that by the other number, and that's guaranteed then to be the correct answer.
Yes.
So yeah, really good. Thank you for sharing. And there's other methods that also work, and that's also fine. If you have a different method for this question or other questions, then anything that works is great. A few requests for looking at square roots. Now, we haven't got time to go into any more detail with the square roots, but you have got the training tool that I linked. And so that's what you can use for trying with the square roots. And the other thing I would say for the square roots is to have a look at what am I saying? Having a look at the list of square numbers that I'm sharing on the whiteboard here. Noticing the last 2 digits, my advice is to look at the patterns in the last 2 digits of these numbers, and you will see lots of shortcuts that you can use to help you with square roots. But we're not going into detail with the like exact methods at this moment. So that's really the end of what I can do here.
Yes.
Questions
Thank
about
you
prime
so much. factorization
and so on. Yeah, there's no end of mental math techniques we can cover. This is everything that we're doing today.
So everyone, I am sure we would have loved Daniel to continue for longer, but there is a limit that we've already exceeded the time limit over here, and he's been very patient and helpful over here and have answered all our questions. With the topics that you think that you want we could not cover in this session, please go back to our referral material. There is material mentioned over there, and you can go through that as well. For now, I would first of all thank you, Daniel, for your time and for taking this session. And it was very, very educative and very detailed, very incisive. And we look forward to working with you in the future as well. And thank you everyone for your time today. We had to shut the session at 6 p.m. But considering it was so interesting and it was so interactive, we had no choice but to extend it a bit. I apologize for that, but I'm sure it has added a lot of value to all of you, and it will help you in your in the competition going forward. With that said, I would like to say goodbye to everyone. Daniel, if you can just wait for 5 minutes after this,
Sure, yeah.
let everyone move out.